I need a very little start, and I see people coming in. And this is our last section, and I think to me it's the most important one to debate based on what we have been talking for 2 days. And I understand, and a number of people has left earlier, and it's understandable they have other business to attend. But more important to us here, it's not about numbers. It's about how many good ideas we can have. And so you guys staying here have the interest to debate future metallurgy and the renaissance of metallurgy, all these topics, okay? And thank you very much for staying on. Roughly, I decided to have 3 questions to be debated. The one is what's going on now, which is about renaissance. Is renaissance going on around the whole world? It's about now. And the next one, roughly is talking about in 30 years' time, what is the, we see, metallurgy 2.0 or sustainable metallurgy, what does it look like? It look a little far. And the third question is about we stand now, how we go there, any actions and any approach we can take. I'm terribly sorry, I forget to mention one thing. Derek, can you see us or hear us?
Yes, I can hear you kind of okay.
Okay.
And I can see you guys also.
No, this is good. And because you are the only person on the screen, and we don't want to miss you at all, and then you can actually participate in this. Okay. So we start with the first question now. I think this is very critical, and I personally, as I said earlier, I do believe there's a renaissance going on around the world, including education, and we see research and industrial development, and also we see the government policies, and also across every sector. I think there's some sort of education going on. That's what I feel. But I would like to really hear your
microphone. Huh?
Microphone. We got a small group of people here. I say difficult.
But he might need it.
Oh, can you hear me or you can't? Dirk,
he needs a microphone.
Yeah. Okay.
I can hear you quite okay. So
he just said whether he could hear you. What did you say, Dave?
I could hear you.
Oh, you can? Okay, that's great. Because microphones sometimes doesn't work with me. Because I do. Yeah, I think it's okay. It's okay to hear me. So, anyone to take up? Yeah, Sean.
Well,
yeah.
I think there is a renaissance in the sense that we have new tools.
Yeah.
In my own case, this Flash DSC has opened up all sorts of new avenues for research.
Yeah.
And my collaboration with colleagues on the fluctuation electron microscopy, I mean, we're seeing things now that we didn't imagine before. This is really important. Additive manufacturing has added a whole new dimension to processing. It has its own issues and challenges, but people are working on that. And there's a lot of emphasis on that. But at the same time, in the United States, the funding agencies are pushing things like quantum materials, and semiconductors. And this has taken resources away from metallurgy. At the same time, in my own department, out of 14 faculty, 6 are computational people. The latest hire is someone who does quantum mechanic chemistry calculations, only calculations. So I'm concerned that in a lot of material science and engineering departments in the United States, the departments are responding to the funding agencies, and it's more emphasis on computation rather than experiment. And this, to me, is a sad development, because I agree with Brian. You have to discover things, and AI and ML are not going to do this for you.
Great. I always agree with Brian. I don't think you, Sean, you raised very two important questions, and actually comments. Okay. The first one, new tools and new processing technologies, which provide new opportunities for new discovery and to refresh our knowledge. I know that's a need for It's sort of an indication of Renaissance. Okay. The other one you talk about molecular. It's an obstacle because currently the government is putting money into something else, which the UK I believe is exactly the same because and like a couple of weeks ago, the Chancellor Exchequer said quantum computing is going to be heavily invested. Yeah. AI here is another one. So it's very similar. Which to metallurgy, to the Renaissance, just making things more difficult. That's your point. That's great. Anyone else going to? Yeah.
Yeah. From my point of view, we have to separate two types of Renaissance in metallurgy. One in research, because there are different tools, modern tools, and then we have to face the industry, which has environment and energy problems. And we have to create a really strong link between. If somebody do research which is not of interest for the industry, we will lose time in this situation. And as I tried to mention today, we have a lot of research done in the past was passed away parallel to the real need. And this is very dangerous if the difference comes to be.
Yeah, it's another very important aspect of the Renaissance is sustainability driven, and there's a need for sustainable future, for sustainable metallurgy. We need to address energy and CO2 loss. That's what I mean. Yes, it's a great idea. Wilfred.
There has been, I think, for 10 years, recently in Europe, a Eureka program, which is called Metallurgy Europe. Does somebody know about what happened with this? What came out of that?
It's guided by the guy from
David.
Turkey.
It's in Belgium, I think.
And
it's running.
ESA.
Yeah, but it's running by the colleague from KIT.
But I mean, there's a whole lot of members, a huge list of members. But so I think this is something one should contact to see how it's
still working.
Okay.
Yeah, I think. Yeah, this is about 10 years. I think. Pam.
I wondered, what would you define as a metallurgical renaissance? So how would you measure, if there is a metallurgical renaissance, what does it look like? What's in the measure of achievement, if you like, of a renaissance? Do you mean that we've now got a greater appreciation of the value of materials and metals, which I think there is? Do you mean that there's more research going on in metallurgical areas, and there probably is some of that happening? I'm just wondering what you mean by what would or is it around more of an interest from young people or the general population in materials, metals particularly in this case? I mean, what is a renaissance in your view?
That's a very, very good question, because we're talking about Renaissance, we have not defined what it is. What do we mean? Okay, it's very Renaissance, and now we can have debate. That's part of the debate as well. And my understanding is that if we got it's an incremental change, everything in metallurgy is going forward. A change of slope. That's one we call it Renaissance. Possible. The other one is a step change. Okay?
To what though?
Yeah. Towards a next level of we see knowledge and skills and industrial configuration. That's what could be.
I think just to add to Pam's comments, a fundamental question is why would we need a renaissance at all? And I think that really stems from looking towards the future, 2030, 2050. In terms of what that future looks like, but what would be the customer base for our materials metallurgy groupings who would be expecting by then to be doing something on their behalf? Who is going to be that customer?
Yeah, well, I think we said that's going to be the second part of the debate. At the moment, we see, today, right in this place, we look at the whole world. Is any sign for Renaissance? There's a need for it, and there's a drive for it, and why it's happening.
But I think that
we look at the future. Okay.
I think that comes back to Pam's point.
Yes.
How do you measure where you are on that Renaissance without defining some metrics of what the Renaissance actually is trying to do?
Well, as I said, I think if business as usual, we do research, industry produce metals and use metals and versus community. Business as usual is non-renaissance. And then there's a huge drive to, okay, I want something to change and something quite different. And I see that some sort of indication of big change, which to me is a renaissance. But it's difficult to define accurately, scientifically.
Well, often it's, you look back, don't you? What you've seen the Renaissance because you lived through it, and then you look back and you realise that there's been progress made, I suppose, but you're not actually aware of it. Perhaps when you're in the middle of it. Is that fair to say? But I think, I mean, in terms of if you were to measure it in terms of is there an appreciation of the value of metals and materials? Absolutely yes. Then we're in a transformational period, aren't we? When we know that extracting metals is intensive. But actually metals are still a lot better than some of the other materials that we're trying to use. So I think in those terms, then we are, because of that appreciation, knowledge and awareness. But does that mean we haven't got huge challenges? Yes, in terms of that energy footprint and the carbon footprint and things like that, and the fact that we're still putting a lot of rare earths and other metals into landfill.
Yeah. That's why I'm thinking with normal, business usual progress, okay, incremental progress. That's not Renaissance, and I think Renaissance is something.
It's more of a step change.
That's a drive for the Renaissance, and you just mentioned that sustainability is one, and also you mentioned, but supply security is also becoming drive for Renaissance. And Carl said it was a huge industrial need. I mean, I'm quite sure he talked about magnesium of 10 years. There's no new production, there's no change. You can see there's needs a step change to make magnesium work as well. Okay, and then Brian.
Well, look, I was away from direct research or involvement in the metallurgical industry either, or teaching of metallurgy for the best part of 20 years, and I came back to it 2 or 3 years ago. So I don't want to get hung up on the word Renaissance. You can go through a definition of that if you really want to, but I don't think that's actually helpful. So what I notice coming back to the field is that there is definitely an enhanced capability. This is very much like what John said, a slightly expanded version, what John talked about his particular activities, but I notice an expanded capability for understanding and making and controlling metals and metallurgical products. And that arises from several things, and I put it in my own abstract. In the end talk about it, although I talk about one aspect. The first aspect, I think that there is that the multi-component alloy material thing has opened up a massive new world of materials we didn't even think about, and in a sense, I can't say it didn't exist. They potentially existed, but nobody had made them or thought about making them. So suddenly we've got a wider range of capability in terms of the actual materials we could make and can think about. But the other thing I notice is that things which are in train when I stop working, which are things like studying things at the atomic level, both whether it's atom probe or whether it's high resolution electron microscopy or some other techniques, and John mentioned a few, or whether it's modelling at the atomic level, that has gone from a rather recherche capability, which was what it was like at late 90s, early 2000s, when I went off to run universities, to now being pretty much a matter of standard recourse. You can do atomic modelling, you can do atomic level characterization, pretty much not by rote. It's not perfectly easy, it's still highly skilled, but it's pretty common and standard to do. So, and we didn't have that before. We were still working at the macrostructural, just about nanostructural level when I sort of went off, and now we're really able to assess and characterize at the atomic level. So number one, more materials. Number two, an atomic sort of level understanding and capability. And then thirdly, for the production, a bunch of processes which are much more controllable, essentially because of the development of better computer technology and AI and control and all that sort of stuff, where I think that really plays best is into the production and the manufacture. So an enhanced capable of manufacture. So a wider range of materials, ability to kind of understand them at a deeper level, and an ability to, in a sense, manufacture them much more controllably. By the way, AM is part of that too. So for me, whether that's a renaissance, I don't know, because you haven't yet got to whether is a renaissance happening, but there's a capability in those three areas, which is, I was quite struck by it, because for most of the time I was off, there wasn't that much change. I go to conferences, I think they're asking the same old damn questions about the same old things. But now, there's been a kind of step change in how people are thinking about what they're doing.
Yeah,
what I mean. Is there a need? Are we going to do something really importantly different? That goes to the issues about sustainability.
Yeah, that's your different question. Thank you very much. Okay.
Yeah, just a comment. While I was
next one's Mark. Okay.
Did you call on me?
No, it's you. Mark. Okay.
While I was dean of the College of Engineering at Florida Tech, the thing that absolutely struck me in terms of a portion of the field suddenly emerging and becoming significant was in the biomaterials part of biomedical engineering, which we started when I was dean. And what was fascinating about it is where the rest of the rest of the college, I should say, in engineering, pick your field, from civil engineering to aerospace, it was about perhaps 27% women. The biomedical program was about 65% women. And within biomedical was biomaterials. And it came to my attention the great interest in biomaterials because of the importance they play in medicine. And this was something that wasn't there. And I saw the great attraction, pleased me to see all these women, bright young women, going into the field because it was biomedical engineering, they're helping people. And the biomaterials is what they suddenly found out is an important element of what goes on in medicine. And in fact, right now at that place, the Burrell Medical School is coming in the next couple of years. If you have a 3.0 average in engineering, you are automatically accepted into the medical school.
But what I mean here, that connection with metallurgy.
Right.
I think you're trying to...
Well, here's the point.
Yeah.
Metallurgy is not missing from biomaterials by any means.
Yeah.
So what struck me is you need something to draw the good students in. This is the part that concerns me, frankly, is getting the bright, motivated students into either directly into material science and engineering or through other departments. In our case, mechanical engineering had a lot of the metallurgy people in it because there was no separate metallurgy department. So I think it's important to have something that the students find attractive, that draws them into it, and the quality of those students ultimately sets, I believe, the quality of the profession.
Marty, you are so right. I think this possibly already answered the third question, how we go there to actually it's an approach to this education part of it. It's good. Thank you very much. And, and I give Mark a chance. Mark is very, use the word eager. Okay, and after you, I'll give Dirk a chance because I'm backing
one at a time.
Okay, good.
So we came here in 2019, the last time for the LiME thing in person, and in those presentations, I know that we had the full metal circulation vision, but the core of the presentations that I've just watched for the last 2 days have literally been totally centered around sustainability, which I think is absolutely is the right thing to do. So in the last 4 years, so since COVID has happened, I feel that everyone was sent to their rooms to look at what a mess we've made of the planet, and I feel that metals have become even more prominent in the direction. And when you can align metallurgy to sustainability, which is quite straightforward to do, and I feel that everything is aligned to that now, and it's just.
So I think your answer is yes.
I think that it's making the gradient has gone up, but I think it still needs to continue to go up.
Thank you very much. I think that's a clear point. And sorry, okay, I gave Dirk a chance. Do you want to participate in this? Because I'm backing you. I will never see if you agree with me.
Can you guys understand me?
Yes.
Yeah, very clear. Okay.
Super. No, great discussion. Thanks a lot. So I think we are in a special situation at the moment, and I think it's not like kind of the gradual development in methods that we experience all the time. I think that is good and fine, but I think that is for me not specifically revolutionary. But what I see as a renaissance, or rather maybe as a revolution, is indeed that we have a total switch in the topics. We must address circularity. Okay, we must address sustainability. That is the biggest topic. That's the biggest thing. We must explain where does the electrical power come from. We just experienced nobody can afford paying the bills anymore, and we don't have a systematic, in the industrialized region, a systematic way of providing electrical power. This power must be again sustainable. So we are back to the business. Do we use hydrogen or nuclear or fusion or whatever have you? All based on materials problems. We have a massive shift towards electrification. The entire system, traffic, industry must be electrified. So all material science. We want to change all our traffic. So again, material science. I think these topics are, to me, a fantastic. It's gold mining time. I always say when people don't see that they sit on a gold mine with these topics, they are blind. They are totally blind. So that is the revolutionary momentum. And many of these things, I think, must obviously be changed. First of all, in very big quantities. So everything we do is big quantity. We are not guys who do small quantities. We are big quantities. And that leverages all, the dumped waste, the CO2 and so on we produce. That means I think we are the guys who will solve the problems about which other people only talk about. I think we can do the solutions. Let other people do the blah, blah. We have it in our hands. And so, yes, I share your feeling, Fan, that we are pretty much in a revolutionary time. And I see it, I don't know about your countries, I see it in my country a little bit that this is, appreciated. Politicians see that, but they get hectical, they get afraid, they give the money they have to some of the big metallurgical companies, but not in the better times that we had. When you think back of research lab like US Steel, or think of Swindon labs, or think of Alcoa labs. These were among the best labs in metallurgy in the world. They were better than many universities were. And this link in a revolutionary time where companies must reinvent their entire business model, I think that's a little bit missing. So I see it in my country being too hectically done, that the money is going to industry directly. But I think we must speak up and make sure that we get, it lined up with the education, with providing younger engineers to the field. So I think that's also kind of a very difficult thing that we have before us. And another thing in terms of education that I find also very exciting, addressing the topics we mentioned before, sustainability and energy and so on, and traffic. We often were educated in a way. There's process metallurgy, there's more the physical metallurgy, okay? And I think many of the topics that are key to reducing CO2 and providing energy, I think they are often between them. So I always say I open my classes on sustainable metallurgy by showing a slide that says, are you a process metallurgist or are you physical metallurgist? And then next slide I always show them through this aha effect saying, who cares? It doesn't matter. You have to solve the problem. And I think we must also in our education make sure that we close that gap a little bit better again between, the branches which are kind of traditional. Yeah. Okay, when you have to reinvent a converter or process or so, it doesn't help you when you define you just to processes of physics alone. I think also in the education we must reflect that, and we must reflect it quickly because we have time constraints that we did not have before. Typically our enemy was a competitor. There was a better product from another company. But now I think the bill will be much, much bigger. So I think I share your opinion. I think it's a good time to make that clear. And we as metallurgists I think we are always living in the shadow. We make ourselves too small. I think we should take a somewhat stronger stand and said, we will solve these problems. I think we are a bit too shy and we are too old. We have lost a complete generation of metallurgists to whatever, bio, nano, and to graphene. I always tell my students, we don't need 5,000 graphene professors. We need 2 or 3 good corrosion professors.
Thank you very much. I think it's very, very clear here. Okay. And Dirk, just let you know here, and you are more, see, the word revolutionary, okay, have not occurred here, but there's elements of it. I agree. Okay. Peter.
Can
Sorry.
I
Next one's you. Okay.
Can I just do a reality check? We've heard that the drivers for this renaissance, if it exists, are principally energy reduction, sustainability, carbon reduction. None of those is a new product. Those are making things we already do more energy efficient. Is there any other? Have I missed something? Is there some other driver out there which we are responding to?
Sustainability.
No,
I think we should
I meant to say sustainability as well.
Yeah.
It's the same issue.
Sorry.
You want to say something?
Dirk, you wanted to say?
I don't quite agree. I think when you say, like we see, for instance, in Japan. Okay, in Japan you have gas-fueled power plants, and they use syngas, they use methane, they use hydrogen, they use ammonia, and even blow metal powder in there. And this is a type of technology that did not exist. I don't know what is hydrogen embrittlement in a cycle turbine between 300 and 570 degrees centigrade. I don't know. But there could be a product, where you say, I sell you a power plant that can deal with different feedstocks. Or saying the electrification, I think it's not quite true to say there is no new product. I think around the electrical vehicle, there are many new metallurgical products. The way you think of the mega casting or whatever, what Musk is doing or so. Or saying, how can I provide, the cobalt and the nickel out of sustainable production, because it will enter a product in a car. When the users of electrical vehicles suddenly see that the making of the vehicle is the exact opposite of being sustainable. So I think there's room for new products.
Okay. Yeah.
But I do think Peter's roughly right. There may be some new products, but most of the technology of wind turbines or direct reduction, we're going to do it somewhat differently, but most of the actual objects you make will be not dissimilar from the objects we currently make. They'll be a bit different shape, a bit different. Now, to make it sustainable, that's still a massive challenge, but I think you're right. It isn't really a set of new objects that we're making. It's a set of modified objects which allow us to do it more sustainably, and we're going to possibly do different metallurgy to create the objects, but you're right, the end products are in some way, the intermediate end products.
There's another point here, according to what Peter said, products, okay. We can understand product in another word with outcome. And outcome is probably wider, and Marx said a circular economy, for example, which is the outcome, which may not be a concrete product, but it's a wider outcome. I think it's okay.
The biggest thing is there's no consumers. No, someone's used the word consumers earlier today. I can't remember who used it. And I'm thinking, we've got to stop using the word consumers. We've got to stop consuming.
We've got to stop them, okay? No consumers, okay?
No consumption. The consumption we've got to stop, not the consumers.
No, it's not consumption. It is custody.
Yes, exactly.
But I think we should not concentrate only on metallurgy. I think this is not a word which we should use because it's not fashionable at young students. I think material science or materials engineering, that's what we go for. And it doesn't matter if somebody studies, plastics. If he comes to the problem of environmental problems, he can take it up. He has the fundamentals, and it's enough.
Okay.
So not only metallurgy.
Point you have, but other people may disagree. I think.
I think trying to combine Peter's comments and Brian's to some extent reminds me of something that went on within the UK for the materials community and all the other technology communities some years ago, and that was looking forward. It was the Horizon program.
Okay.
And it was It was initially technology foresight. And all sorts of people jumped on the bandwagon and understood it. But foresight then changed and it morphed to a more strategic observation. It was called quality of life. And I think that there are elements that Peter was talking about which can be all embraced in quality of life. I saw in that program many of the areas that you could define as technological areas stop and falter. But I didn't see the stopping and faltering within the materials community, because they started to understand where those developments were affecting quality of life. And the materials community actually came out of that foresight program incredibly well. So for me, if you wanted an enveloping strategy associated with materials, it would be to improve the quality of life. And I think that comes back to Marty's suggestions in terms of the biomedics and so on and so forth.
Yeah, it is a good point, okay? And
Thank you.
you're too close to me, that's why.
I actually think question one, as you've got it on the screen there, I actually think you get different responses from different stakeholders.
So I think
as a metallurgical community, and you see the energy and the excitement of this event, we'd probably all agree that yes, the world is moving rapidly, and it's a vastly different place to when we started our careers. And if you talk to the world's biggest construction companies, transport companies, food and drinks companies, do they perceive that there's a metallurgical renaissance? Does the future talent pool perceive that there's a renaissance? I'm not sure, and I think that comes back to the comments we were making yesterday afternoon. We do need to do a better job of kind of the public engagement side of things, not just have this debate amongst ourselves.
No, I think publicising this is the next job. I think at the moment, and I think in our mind, is renaissance going on or not? That's the question we're debating.
I think Mike's exactly right. He held up his Coke can and said, I get this drink in a free can. If that can cost you 5 cents, you might have recycled it. And he showed an airplane, the A380, I think it was, and the people in the plane were ignorant as long as they felt comfortable that this plane was going to land eventually and take off. So we don't do a good job of public relations in the general population. They get in a car, and if the fuel economy improves, that's good. You don't care that it was a magnesium part or an aluminum part or a steel part, as long as they pay less at the gas pump. So we have to do a better job of public relations, and maybe the professional societies should be responsible for that.
We agree on this. But
the Coke can is a great example.
They
say, you've got it. Jeff will give me the exact numbers, but they say when you buy your Coke can, you're paying 5 cents for the Coke, 40 cents for the can, and 60 cents for the advertising.
This is not
that's what they say. I don't know what the exact numbers are. So you're buying a Coke can.
Here, I would insist that we focus on this. Otherwise, we're going to see us tomorrow morning.
Too much for the content.
Okay, one second.
Metallurgy relations, is that happening or not? And I think I totally agree. We need to engage with public. Public awareness is very good, and Mark Mildonic is doing a brilliant job for us for that. And that's why he's called Brian Cox in engineering. And I said, this is no problem with this. But at the moment, focus on renaissance. Is it going on or not? And
I think we have the nucleation.
So your answer is
yes. By the way, Mike, in answer to your questions, I personally think, and others may disagree, and there's people like Mark who will know better because he's closer to it than others in the room. I think companies do know that something's happening. There isn't a company that I come across that isn't worried to death what's going to happen in the next 10, 20 years, and will they still be around, because they know there's a lot of change coming. Do the public know? I think the answer is no. So you raised two questions. What do companies think? What do the public think? And I think the answer is yes and no. That's my...
But the companies, this is another matter. Companies to do with policy and to do with business models, all this. And earlier we had a discussion with Bernie. I think, for example, if all the cars and the car manufacturers own the car, we just drive the car and we just take us from A to B, and then metallurgy metals becoming precious to them, the longevity, everything, and they're going to be happening. At the moment, there's no way we're going to have a car. We will talk about the longevity for 20, 30 years. That's impossible. So that's a complicated issue. So another one. So at the moment, I think I can see these are very tangled and so many factors, but can we focus on from scientific, technological point of view, is the renaissance happening? I think I can realize. I think we need to be quite narrower, otherwise we go forever. Okay. Yes. Okay. My colleague got a.
Yeah, I thought that the future metallurgy renaissance depends on the need of the industry. So if maybe we have a solution. Every factory they have a selling department to make profit. So should they have also a recycling department to collect their own product at the end of the life? Then we can resolve the recycling problem and also the.
Well, that's where legislation has a lot to do.
Yes,
we understand.
EPR and DRS.
Yeah, so that's really happy with that.
That's policy and all this. We know that's very even more complicated with we can have debates. But now we focus on research, technical, scientific issues, technological issues, industrial configuration maybe. Okay, but if you go beyond this, it becomes more complicated. We can't have any feelings and also very much of our time. I think. Mark, you're the last one on this question, okay?
Just to ask a question of all the metallurgists in the room, and it's a simple yes or no.
Yes,
Put your
like
hand
that,
up if you think there is a renaissance, and if you don't, keep your hand down. You just have to do it now.
Yeah, Mark, great idea. People agree renaissance is going on. Raise your hand. And someone going to count and say, I tell you, actually less than half, okay?
I hope you counted, because there's going to be a split.
The point is, if we all believe there was a renaissance going on, we'd have had at least 85% of people put their hand up, and we didn't. We probably had less than 50. Do we need a renaissance? Is another question. How about we do that? One more question.
Mark, I don't understand where you come from, okay? Now, we're going to focus on renaissance happening or not happening, okay? Yeah. So what do we see, okay? People believe renaissance is not happening. Can you raise your hand? And see, oh, that's less than 1/3. Mark's point of view is very good.
That's a truth. That's a truth.
You have to double check people who don't know.
It's no.
Yeah, okay, I think it's a good point, okay? If you are not sure it's happening or not happening, can you raise your hand? Not me, okay? That's 1, 2, and a few, okay? Okay, you can see overall, probably see, okay, there's less than half people, probably about 40% saying yes, and less than 30% saying no. That's probably a couple percent saying, I don't know.
With 20% error.
Perfect. I think there's a start, but it actually needs to continue to grow.
I'm very pleased with the outcome. If renaissance is not happening, the second question is no need.
Can we go home now?
So, okay. I'm very pleased. Thank you very much for...
I would disagree with that. I think the future metallurgy and the elements for what the future metallurgy will look like, it needs to be addressed. Either there is a renaissance or there is a progress.
I agree.
I mean, not having a renaissance that does not mean...
That's even more important. Brian and our colleague from Field, they agree, okay? Yeah. So now we're going into second question, okay? If we see, okay, there's a chance for future metallurgy, what does it look like? And we have a very clear timeline by 2050, because globally we see 2050 we need to achieve sustainability net zero, all this, okay? So by 2050, we close our eyes, look forward to see, okay, what's the new metallurgy, sustainable metallurgy.
You do need to be very clear, Fan, and Wilfred's question is a very strong one. Whether which needs to be decided in advance. Are you talking about metallurgy or are you talking about materials?
No,
so it's very important. Well, Wilfred argues that you shouldn't talk about metallurgy because it's part of a bigger subject. So it's important to decide.
Yeah. No, different people might have their opinions, I think. And my personal opinion on this, I think, I always claim myself a metallurgist, hardcore metallurgist, and my personal view is the downfall of metallurgy was due to the merge of all sorts of materials come together in material science engineering. I'm not saying that's wrong. I'm saying metallurgy should have a clear identities and not losing its momentum. And that's my personal opinion. But okay, I accept that suggestion. Okay, we have a quick debate. You see, is metallurgy needed or not needed? We just have material science and engineering and the MSE. Has been the case since 1960s. Okay?
Well, you commented on plastics, and my view would be polymers are sufficiently different from metals, and ceramics is more difficult, or semiconductors, but polymers are sufficiently difficult that both the industrial drivers, the sustainability issues, very obviously, are very, very different to those for metals, but also the processing is very different, and they're sufficiently different that it's quite hard when you teach material science. You notice there's quite a sharper division between the polymer side and many of the other materials. Semiconductors and to some extent and ceramics, I think, are part of a clearer group of materials that have some similar issues, some similar.
So you're talking crystalline and non-crystalline.
Well, to a large extent.
This is going on, Brian.
I think
that's
my opinion is we need material science, and we need the basics of material science. That's the most important thing, and this covers everything. This covers as well crystallography or polymer science, whatever. But I think if you have these elements of the fundamentals, you can solve problems. What Dirk is calling on, and what every other people
think.
And they are flexible for the future.
And then go to polymer and all this later on.
Yeah, but I mean, you can change to metallurgy. Young people are very flexible if they have the fundamentals.
Okay.
I think this is the most important thing.
Thermodynamics, microstructure, many of those things are very similar. I agree. So I was part of the material science movement, and I'm a believer in it, really.
I think that sort of crosses over them, Peter, the points that you were raising earlier, insofar as where the science and the engineering play different roles. And personally, I feel that there are different attributes to the people in both of those sections. So I was very supportive of the way in which Peter was trying to develop the concepts of what a scientist would develop, as opposed to what an engineer would develop. Both of them have a role in terms of the development of material science and engineering. But I tend to feel and support the idea that engineering is better coupled to industry need, quite frankly, than science would be.
But you need mathematics, you need chemistry, you need physics, you need some fundamentals which everybody needs, an engineer or a scientist.
Perhaps you do, but the scales associated with those two are, in my opinion, really quite different.
Okay, that's good. And then we recently a foundation for material science engineering, which include metallurgy. That's probably the general idea.
Right.
And any other comments before we go to Mark?
All I would say, and I get the whole thing about material science versus metallurgy. I think if we are focused on net zero 2050, and then we look at what are the problems, it was clear from the first presentation yesterday that metallurgy and metals are one of the key focuses. So we mustn't let metallurgy get lost in material science. It still has to be a dominant research focus.
But why did metallurgy as a name kind of disappear?
Because it's dirty.
No.
Look at Foundry.
Talk to the universities. Metallurgy, ceramics, polymers, glasses were all taught as separate degree subjects in the UK.
Yeah, earlier.
They were amalgamated to material science and engineering because those individual subject areas were not sexy enough to draw the students in.
Yeah, correct.
And then more biomaterials, sports materials, aerospace materials. Young people could see the vision of where their career might be going. It was an easy fix. For material science and engineering was a need of a fix for the university entrance.
No, I don't think so. Because if you produce something, you have to use the material which is best useful for this purpose. And so it could be a polymer, could be a metal, or could be a ceramic. And there you have to have a wider education.
Bernard, you weren't in the university, so let me tell you what actually happened. What happened was partly what you said. So there is no doubt that kids coming out of school were finding the attraction of a study, in Britain particularly, where you entered to do metallurgical science or ceramic science or something, they were finding it less attractive. You used the word sexy to mean attractive. But that was only part of it. To be honest, the universities didn't just respond to a demand. They also responded to the fact that to a supply issue, which was quite a lot of the teaching going on in your ceramic science department, in your metallurgical science department, was similar, because you're doing the thermodynamics, the same math, the same underlying chemistry, and so on and so forth. So it was a bit of both. It was a bit of both.
Thank you. But there's change of condition. Okay? It is past, I think, why ceramics, polymer, and metals merged into material science engineering. That was at that time there's a need for that. But at the moment, okay, metal is coming back or not. There's another, sustainability issues and all this coming back create a new condition. That's why we are considering reconsidering.
Mark has a really good point.
Yeah.
That the need for metallurgical development is growing quite distinctly
Yeah,
from the need for polymer developments, which has a completely different issue. With polymers, not having them being waste products is completely different from.
But then find another name than metallurgy. You can
I
connect it to metal or something like that.
I think that there's an opportunity now. So metallurgy, so it obviously died off in the sexiness or whatever it was, but I think that there's an opportunity now with circular economy and sustainability to actually traction around making it sexy again.
Good. Do we call it then something like
I don't know the word.
Sustainable metals. Something like sustainable materials.
Sorry, Mark, our colleagues can't get it.
So I'm not a metallurgist. So
That's good.
I'm
You
an
can have your own opinion.
As an industry viewpoint.
Yes.
Get out of here.
I'm joking. It makes you feel better. I have a PhD in nanoscale.
Should call me metallurgist.
I'm an alcoholic. Oh, no. Wrong meeting.
Serious of it.
So my point is that part of the reason this became unsexy is because these materials are viewed as a commodity.
Can you speak up a little bit?
These materials are viewed as a commodity. These are commodities in high volume manufacturing, and they are bought at the lowest price possible. Energy, CO2, that doesn't matter right now. That matters in 20 years to industry, and then they'll panic about it and hope that you guys have solved it. And they buy at the lowest price possible to a specification that was set 20 years ago, or longer, quite possibly. Probably by a metallurgist, but now they've got rid of all those people because they're too expensive, and they're just buying to the same spec as low as they can go. And the problem that comes with recycling, they don't want to buy recycled material because it is not, exactly the spec on
not
their
in
bit.
spec.
How do they prove that?
That's what public awareness on all this.
Exactly.
We need to communicate with them.
This is where you've got your problem with metallurgy.
Yes.
Is it's seen as a commodity. It's seen as a commodity product.
Yes,
that has to be changed.
I think perhaps is the sea change then coming because now, our members are being asked to look at their supply chains and report on their Scope 3 emissions.
Yes.
So suddenly there's an incentive to look around maybe and to look at whether we call it low carbon materials or sustainable materials or whatever you want to call it.
But
is that going to be a bit of a sea change?
Yes, but it comes to the effectiveness of that regulation, because we're heading towards net zero. These companies have net zero commitments, but net zero does not mean zero.
No, it means less.
It means less.
Yes.
And stuff that costs me too much to do.
Yes.
I just put some money over here.
It offsets.
I would
and
decouple
it's fine.
the cost and the pricing and all this, okay? Because the cost itself is part of policy making process, okay? If you can change, for example, at the moment, 1 kilogram potato costs equivalent to 1 kilogram steel, okay? And how is that going to work? In terms of CO2 terms and energy terms, okay? But that we come back. And I think metals, for example, gold, why gold is more expensive than aluminium, for example? And there's no reason. Equality, what is equality of destruction? And gold, who made the gold more expensive? Okay? It's not gold, it's more precious or anything. It's just people think gold is more expensive. And it's policy. Okay, we come back to metallurgy. I don't think probably I'll just make one more point and then we leave it, okay? And we go to the next question. And from yesterday morning until now, there's a repeated set of one thing, okay? Metals, as a single factor, contributed to the CO2 and energy consumption, largest single factor for climate change. And if we all believe net zero or climate control 1.5 degree and all this, we need to address metals. That's what I would feel that's the case, okay? So we will leave to this question. And now we go to the second. And people agree or disagree renaissance, okay? We go to the second one. Just imagine what was future metallurgy going to look like. I'm not going to talk about renaissance anymore. I'm talking about future metallurgy, 30 years time, 2050. What's a major, we cannot push a big picture here, but we see elements. Everyone can contribute. What do you think that's major characteristics or elements of it? Okay? And I'm going to stay further away so I can see people raising hand. Yeah.
If I may share my opinion here, I think that, we may agree or disagree if there is a renaissance, but I think, many of us would agree that we need a renaissance, we need a revolution of metallurgy and materials in order to go to net zero. And I think that means
we pass that question. We agree with you, yeah.
And we will need, I think, to have more sustainable metallurgy concepts similar to what the concept is saying. Okay. And then we need also, I think, development of materials and metallurgy which support a clean energy production.
Okay, thank you very much. Wilfred,
I think what I realize normally is the chemistry part is often very weak in the education in material science or in metallurgy. And I think the chemistry part is one of the fundamental things for the future. for the recycling, there's a lot of chemistry elements, and many of these young people are not well informed about that.
Okay.
So that's one is to treat.
Yeah, it's a good point. Please, sir.
A bit of one of my slides, which I didn't actually talk about because I was rushing, I put chemistry versus physics. My perception is when I came into metallurgy, and by the way, I came in because my uncle told me I wasn't clever enough to do physics. So I'd better do
He was right.
He was right, yeah.
You're talking wrong.
But Peter, you had 2 pieces of paper that said you
Yeah.
were very clever.
Quite clever. What was my point?
Physics and chemistry.
Yeah, physics and
Versus
chemistry.
physics,
Yeah. When I joined metallurgy and became an academic, everybody around me was a physicist. In the materials departments and the metallurgy departments, everyone had been a physicist, basically, one sort or another.
Yeah.
Now when I look round, I see many more chemists around. So I think that change to perceive the chemistry is underway, is my perception.
So that both of you agree, and is future metallurgy, chemistry becoming a big element. That's what was weak so far. Okay.
Just a comment to the last comment. Just a comment to you. The reason things have changed that way, and I see it among the physicists, is their, somewhat clever term of squalid state physics. Okay, and there's definitely a down-the-nose look at solid state physicists. So the physics world is changing to the sexier stuff, quantum physics and astrophysics and you name it. And I think that has actually throttled down on the number of physicists who call themselves solid-state physicists. And I think that slack is picked up by others.
Yeah.
And I think there is a change in the mix for that reason, because the physicists
It's two.
themselves
Yeah, you're right, Marty. It's two reasons.
don't have a great look at
There's
it.
been a downgrading of solid-state
Yes.
physics within the physics community because of the upgrading of certain other areas. Have
Right.
become, but by the same token, in the chemistry field, they've moved to larger scale problems. They were dealing with small molecules when you and I were students, when Marty, you were a student. Or a young lecturer, but nowadays they've moved up. That's why they deal with biomaterials, biochemical issues, and they deal with what they call materials chemistry issues, which are larger scale things. So there's more chemists involved, and all those functional materials have become more important. So I think
chemistry is important.
that's the change of mix. But I think that's a good thing, because I think physics is important. The physics of materials is very important. The physics of metals, and I think the chemistry of materials and the chemistry of metals is very important.
But physical metallurgy, and it's a lot of part of physics, but metallurgy itself, that's one big factor. Metal structure and physics don't look at. That's the difference between probably metallurgists and physicists. We look at different ways. Yeah.
There's no merit in going around lodging shopping about different subjects in this way. Yeah. You get nowhere, because you end up with the classic thing I always used to say: the physical metallurgists hate the metal physicists, and the metal physicists hate the. It's what they call what was it in the Russian Revolution, the Bolsheviks hated the Mensheviks, and the Mensheviks hated the Bolsheviks, and they were after the same thing. They were incredibly close.
We need both physicists and chemists.
We need them both, exactly. It's another of those and.
But what Wilfred's point of view was, chemistry was weak, and I think I tend to agree with this, because we too much focus on physics sometimes, and chemistry was becoming weak. And for example, at the moment, I think composition, we have not very enough. And as well, for example, recycling, we are having this problem, tolerance issues and all this. I will see Dirk would completely agree with your review paper. So
I think it's actually more interesting to move to question 3, if I may.
Okay.
Because I know you want to focus on question 2, but actually number 3 is the bit that's going to make any difference.
Okay.
Sorry.
No, I think you're right, because number 3 is connecting 1 and 2. But I also realize, Mark, you got some comments?
Yeah, I mean, I agree with both the physics and the physicists and the chemists. We need both of those. One thing, it says, what are the essential elements for future metallurgy?
Yes.
The one thing is almost a reverse. What we don't need to do is develop obsolescent research. So I watched all of the research at the carbon fibre and all of the research at the graphene, and knew 5-10 years before we came to the conclusion that we're rubbish, that we shouldn't have bothered. So it's the only thing that me and Harry agree on, that graphene is just like, dead in the street. So the essential elements of future metallurgy should be focused on the world problems, not on science for science sake, and that's from the engineer, I'm sorry.
Okay. Good point.
Killed by attribute, Brian.
Sorry, I got a TV that push through. So, anybody got a couple of comments on future, what picture of sustainable metallurgy before we accept Pam's suggestion? We go to the third question, actions towards the future. But I don't know where we're going.
I want to make a comment. Look, Mark, I actually don't agree with you, to be perfectly honest. You capture one of the most important issues, which is industrial, or more accurately, not industrial, because I think the whole issue about making money is a side issue. It's a question of creative value and goods and wealth and health for people. So, are there important drives that we need to take account of, which is what you're arguing? The answer is yes, of course you have to. But science for science sake is also important. We have made progress by a valuable discussion between those two drives. So the drive to understand things, because we don't understand them is a very important drive, and it's the marrying of that with those drives because we want to achieve things for our people, for our society, whatever it is. It's the marrying of those two that works well. You don't say one and not the other, because otherwise you get stuck into technical developments without necessarily the capability, which actually comes from the science for science sake.
I think we should be doing science for science sake, but we should have the fail-fast principle where we don't just go down the rabbit hole because everybody.
I agree with that. That I agree with, of course.
Okay, I think we can agree on that.
And graphene became that.
But you two agree with each other. That's good. Okay.
But by the way, the graphene thing was a way that material scientists, and this has happened in other areas, used a certain amount of hype, as everybody uses hype, to try and get money from the government.
Yeah.
And so they go down the rabbit hole because they get paid to do it.
Okay, I think
it's not a good idea. I think
it's good discussion and including debates as well. So, shall we move to third question? What's the actions and approach we need to? No, I'm not saying towards future sustainable metallurgy. Towards the need for metals to be sustainable in the future. And then we change the subject a little bit, okay, because which may not be scientific. Dirk, did you want to contribute or?
No.
Okay, so we are going to the third question. Okay, discussing what's actually the approach. Okay, let's go. Okay. We to be honest, we only got less than 20 minutes. Okay. So
Marty had his hand up.
Sorry.
Marty had his hand up.
Yeah, Marty, you got a
I just had a question. I mean,
yeah.
Is there even a question? I certainly don't see it. That metals in the future wouldn't be sustainable. Of course. I mean, if you look at the range of properties that we've been hearing from, the light metals community, steel and so forth, there simply are no other materials that will take their place. They will be here forever. Now, we know some of the steel goes into buildings for 100 years, but eventually it'll come out and be recycled. And that's true. We have 14,000 airplanes floating around, mostly aluminum. They'll be recycled eventually, and everything has a life. So why? My question is, why is, I don't know, is it a worry or just a question about sustainability of metals, as you put it?
It's marketing.
It's marketing.
It's the public perception.
It's the public perception. We're trying to make an argument for valuing materials that we know are infinitely recyclable, but we're telling them who don't know. I think that's the point, isn't it?
What do they think? Consumer and the people coming in who need to be educated.
So we agree, absolutely. Of course they're sustainable. That's why we're spending all this time looking at how we recycle them, because we know that, but they don't know.
The next generation, the consumer,
it's everybody else. It's the great public and young people and everything else who don't appreciate the can, the plane, the materials that it's made of, that are not paid for it, that don't value it. Suddenly we're having to pay for it because of the carbon footprint, so it becomes more valuable, so we can attract more investment in the research that enables us to do those things. I'm with you.
Wouldn't that be an issue for the ASM, the British equivalent, and so on, the societies, the TMS, and we know that those societies handle and juggle everything from the science to the production. Okay?
Yeah, but despite their best efforts, Marty, the real problem is the percentage of primary metal in steel and aluminium, and to some extent in other materials too, particularly some of the critical, rather small, but very critical metals, the percentage of primary going into them is greater than technically is needed. There's more secondary material, in other words, that is not being recycled effectively, or being used for its full longevity before it's recycled. So there is a potential for reducing the total carbon footprint of these components that are made from that, from those metals, by using less primary and more secondary metal, recycled or reused or whatever, and by extending the lifetime of the usage. So, but the problem is it's not happening naturally. You know, if the ASMs and the TMSs of this world were doing their job, they would already be doing that, and they're not. So there is a problem to be solved.
Just let me add this, Brian. I can't think. My first Metallurgical Society meeting was 1957, just to put a time marker on it. And from 1957 to the last one I attended, I still see the same aluminum reduction sessions where they're talking about trying to reduce the amount of CO2 produced. And it seems to me, as long as they're selling aluminum, it's not happening. So either the government has to step in and say, look, for primary...
Yeah, you're right.
Yeah.
Yeah.
And
but the question, the issue is...
No,
you're right. The issue is, what is the fulcrum of activity?
There is a price on carbon now, isn't there?
Pardon me?
There is a price on carbon.
Yeah.
There is a cost to carbon.
Well, maybe that will do it.
Because carbon taxes, the carbon...
That may
the
finally
carbon,
do it.
And I think that's the change that's only happened in the last 3, 4, 5 years.
That's the governmental
so now,
action.
yeah, it's governmental because
Yes.
we realise. So I think that's the point, is that there's an opportunity there to use that as an incentive. And to say our members are having to being asked to report on their scope 3, so they're having to address circular economy and put a cost on things, and that's the opportunity, I think, for us.
Sorry, John. Can I connect the sort of comments that Pam and Marty were making? To level it, I was running one, so I know what it is to do professional organisations. To level it simply at a communication need from professional organisation is wrong. This whole community is responsible for the communications game, and we are lousy at it. So from the point of view of an example which I shared with Pam yesterday, every single one of those posters down there in the chapel should have had a small board by the side of it, specifically saying what quality of life improvements could be expected as a consequence of that technological innovation. That's the communication piece that we are all guilty of not providing to a broader community. Then you wouldn't get this situation of the broader population not fully understanding what's going on in the metals and manufacturing area. We should aspire to being the top communicator. And it would be nice to think, give us a challenge. 10 years' time, we're at the top of the league. The column inches that are filled with metallic advantages should be something that as a community we challenge ourselves to deliver, not just park it with somebody else to do.
But we in the UK, we've only produced one Mark Me Dovnik so far. And frankly, we need more of those.
By the way, you have explained perhaps why the biomaterials has done so well, because it's almost self-explanatory that if you're coming up with a new material for stents or some other effective way of delivering medical care and comfort, that takes care of itself because it's so close to people's understanding.
Exactly. It's closer to the community who appreciates it.
Yes. I agree with your explanation.
Okay, can we see, okay, we're going to close this debate. We see, okay, we all agree communication is very important, particularly communication with the public. And it's not scientific, the research community, it's general public. And I like the idea that we only have one UK, $1 million.
We need the cloning program.
We all need to be like Peter, sorry, not Peter, Peter is
fine. You all need to be like me, I'm sure.
Yeah, like okay.
Well, a good example occurred yesterday with Lindsay. He published this paper, and all of a sudden it got all this attention, even though he thought it was wrong.
That was my question. That was John. I would believe. He did a wonderful job, and a popular paper.
You have to get it into
Joe Biden attention. And I found out it was wrong. I said, did you tell Joe Biden that's wrong?
but you know, that getting that out into the public and you know into the business community where investment is made, all of a sudden the general public sees it.
No, I'm absolutely right. I think LiME is one paper published this year. We list all the publicity, okay, and we don't have this sort of capability on even intention. I think we need to have this increases level, okay.
Bye bye.
Thank you very much.
If it takes you.
Yeah. Okay. Okay.
Bye bye.
I think we got about a few minutes, and I'm not going to receive the sort of questions. Anyone have any very important question to raise?
Just a question. I can just comment and probably just in the comments.
Yeah, you can. You have your chance.
Just present here. Well, there are three questions. It's very hard to say whether metallurgical renaissance is happening or not. It just depends on the level of just whether we scratch material science or we dig too much about and we know already everything about this. And definitely sustainability and recycling is very important. And there were many talks already at this conference which were mentioning all the elements of this future metallurgy. One of them I especially liked by creating this specific platform in Manchester, in Henry Royce Institute, in which everyone would be just feeding all the data, all the compositions and whatever you can Google through this platform, but for just and afterwards you can trust this information and you should repeat some experiments.
Should you trust that?
Yeah, definitely. Yeah, somebody should be checking, and you can trust people around you. And just imagine if everyone just from all over the world could be feeding the database, and you can Google through it, and afterwards, artificial intelligence will be doing the job. This is probably future metallurgy.
Thank you for the point, and I think there's quite a lot of debate from what you said. Okay?
And probably I would add, if you want to change something, probably best to start from yourself.
Me?
Sustainability and education matters, of course.
No, but I kind of understand what you mean. It's changing public perception and awareness start from everybody. That's what you mean. Okay? But that's a good point, actually. Any other comments? Your last chance. I think, Mark.
I think changing public perception, raising awareness is part of it, and it's the start of the process.
Yeah.
Ultimately, what we need to do is provide people with the information and tools for them to make more informed decisions.
Yeah.
Let them turn to our materials, our metals, because it's the right solution for whatever application they're going for. At the moment, I think there's a lot of the kind of like the design decisions are being made by people who just don't have the information. Yeah. Our role is to put that information into their hands and allow them to make better decisions.
Thank you very much. That's good. Good approach towards future. This is good. And anyone else got any last minute comments on want to make a be brief as well?
Regarding this, the sexiness we've just talked about. So we've been talking about this for 7 years.
We don't talk of sexiness.
but how can we? So we talk about it at every meeting, but how can we actually action that as something? So we've got people from all over the world, and how can we?
It's a good question, and I think I will leave everybody to think about it. Thank you.
Well, I think you should invite the news media to come and tour the labs and show them demonstrations, and have your local members of parliament come, invite them.
Okay. We invite them all the time and they don't come, that's the problem.
Well, we've had all that type of thing, yeah. It's just
have a reception.
It's about going into school as well.
It ain't that easy, believe me.
John,
I've done a lot of this, John. It's not easy.
You have to go to them.
Oh yeah.
They're not going to come to you.
Right. That's what I'm saying.
We got Boris from our lab, okay? And he knows aluminium from bauxite. Anyway, it's a good point.
We have an expression in America: the squeaky wheel gets spoiled.
Yeah,
so
totally agree with that. Okay, we need text actions also. I think I totally agree. And can I just very quickly sum up with this, and without summary, it looks like it's not complete again. Nearly half people believe Renaissance is happening, and there's probably approaching 1/3 people saying no, and a few people saying I don't know. But anyway, it looks like we have a general understanding of it. There's a difference between different opinions among people. Okay? And we have not probably debated the second question, what's future look like, but I'm sure you might what's needed done for sustainability and all this. Approach, we have been talking from the very beginning. I think there's lots of approach being mentioned here. But anyway, I think this is a very useful debate, and I really like everybody's so passionate. You can see the passion for sustainability, debating on all this. I'm sure sustainability is going to be, for metallurgy 2050, it's going to be sure thing. It's not going to be no doubts at all. And then I come back to say, okay, I know a lot of people have left, and thank you very much, everybody, for coming to participate in this forum. I call it forum, not call it a conference or anything, because it's invited only, and based on IAP, and also some invited speakers, including Dirk and others. Okay. This is a test of water, and I think so far, from my point of view, I think it has been brilliant. All speakers, and it's very high quality talk. Lots of ideas, lots of aspects of sustainability of metals, and I think everybody in their mind have some sort of a picture what the future metallurgy look like, and how we go there. Okay? And I'm very pleased with the outcome, and I thank everybody for the contributions of this. And it's always very important. It's not me did the organization; it's my colleagues. I think. I think time probably already because Keith, Cass.
Have to take all the credit.
Yeah, okay. So the only one person left. You saw him, the tall guy there, Phil. Thank you very much.
Catherine's at the back. Catherine.
So Catherine?
Catherine's at the back.
Yeah, sorry. Sorry, thank you very much for this. Normally at a conference, and it ends like this, and then after clapping, and someone going to deliver flowers. Okay. For circular economy, this time, sorry, we are not going to do that, but we thank you the same. Thank you very much for all this. Okay. And that big question, I'm not going to ask you to answer that question. Is there a need for similar thing going on in the future? And we can organize ourselves and for next time. And I'm not asking for answer, but think about it again. If you have an opinion, let me know through email all this. And finally, of course, we cannot forget our colleagues sitting on the screen. Dirk, and I think we are closing the session. And see, do you want to have anything you want to mention? Before we complete the final word.
No, I don't have famous final remarks. That is always a dangerous thing to do. So I'm very thankful that I could participate remotely. So I think it was a very inspiring meeting. Thanks a lot.
Thank you very much, Dick. That's very good. Finally, I wish you, if you're going home, have a safe journey. And thank you very much. I'll see you very, very soon for a similar occasion like future metallurgy. Okay.
Well done for holding this together, Fan, because it was kind of going off in tangents. So fair play to you.
Yeah, thank you very much. Thank you. Okay.
Thank you.
Thank you.